Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's use the limit theorems to evaluate the limit of this given rational function. We have here the limit of a rational function. Our numerator, we have 2x plus 1 over our denominator, x squared minus 3x and plus 4 as x approaches to negative 2. Now, this is very important to be remembered, as this is the limit theorems are possible as long as our denominator here is not equal to 0. But of course, if it's not, then the limit doesn't exist in that case, right? So we are going to use here two different methods, two different steps by separating them so that you can have your two options and solving for the limit later. Let's start with the limit theorems aside from the limit theorem for rational functions. So let's have here the limit of the numerator alone as x approaches negative 2 over the limit of our denominator x squared minus 3x plus 4 as x approaches to negative 2. Okay, so you will have here the limit of 2x as x approaches negative 2 plus the limit of 1 as x approaches negative 2. So we're using here the limit theorems for the quotient, the limit theorem for sum and difference, and later on power and product as well. You will have here the limit of x squared as x approaches negative 2 minus the limit of 3x as x approaches negative 2 plus the limit of 4 as x approaches negative 2. Then, of course, as mentioned, we'll be applying here the limit of the product and the power on the denominator. Limit of 2 as x approaches negative 2 times the limit of x as x approaches negative 2 plus the limit of 1 as x approaches negative 2. All over, we have here the limit of x, you square that, that's for the power, okay, minus the limit of 3 as x approaches negative 2 times, that's negative 2, the limit of x as x approaches negative 2, then plus the limit of the constant 4 as x approaches negative 2. Alright, then we solve them step by step. The limit of the constant is 2, limit of the identity is this, plus the limit of the constant is 1 over the limit of the identity is negative 2, but you need to square that because you have the power there, minus the limit of the constant is the constant itself, the limit of the identity is this value, then plus the limit of 4 is 4 itself. So we have here negative 4 plus 1 our numerator. This is positive 4, positive 6 plus 4, right? Equal to negative 3 over your denominator, which is 14. So that's the result for our limit of this rational function using the other limit theorems. But of course, we can write here and use there automatically the limit theorem for a rational function as long as mentioned, the denominator is not equal to 0, so it would be existing. So simply substitute. You will have 2 times negative 2 plus 1 over, you have negative 2 squared minus 3 times negative 2 plus 4. So you can see this is just similar to this item here. Okay, so this would mean this is just 2 times negative 2 is negative 4 plus 1 over, you have 4 minus 6, plus 6 plus 4. So negative 3 over 14 is just the same as this. This would mean that any of the two methods is actually acceptable, but it is of course shorter than that because we already have the limit theorem for a rational function. I'm just comparing it so that you will have your options as well later. So what are you waiting for? Subscribe now